Okay, thank you, Sabrina and TC for the introduction. Hello, everyone. Hope you are all doing well and staying safe during the pandemic. And my name is Qiusheng Wu. I'm an assistant professor in the Department of Geography at the University of Tennessee. Today, I'm going to briefly introduce you to the geemap Python package that I developed during the past few months. And you can access the Google Slides by scanning the QR code at the lower right corner, or you can type the link, the URL. I also put the URL in the Zoom chat box, so you're welcome to click. Know that the PowerPoint has a lot of images, so it might take a while if you scan the QR code using a cell phone. So I would recommend that you use your computer to look at the slides. And so let's get started. So here's the outline. First, I'm going to talk about how the reason behind why I developed the package, and then I will briefly introduce you how you can get started with geemap, and afterwards I will give you some resources and tutorials, and at the end I'm going to demonstrate some of the key features of the package that you might be interested in. So if you look at the right here, on the right here, this animation. So this is the one that I created using geemap, and you don't need any source code. You just, if you like, you can click the link to try it out. I can briefly demonstrate here if you're interested in. So basically, this is a Jupyter notebook, and you can turn a Jupyter notebook into a website. And then from there, you can, if you want to create any animation, for example, using Landsat data, for the past few decades, from 1984 up to right now, you're more than welcome to. Also pay attention because I'm using kind of a free version. If too many people are accessing the link, you might be timed out, so I don't know. But I can quickly show you, for example, if I'm interested in surface water. So for me, I would like to see the surface water changes on the landscape during the past few decades. All I need to do, draw a rectangle, and then you can select anywhere. And at the bottom here, you can change the length combination. For example, you can change the title. You can change, for example, I would like this one. You can change the font color. You can change the progress bar color. And all you need to do is hit submit. You can adjust those parameters. And it will only take probably less than 1 minute to give you animation. So this gives you a quick way if you want to see the changes on the landscape anywhere on Earth, and you can use the all available landscape images to create this kind of animation. And so you can draw a rectangle. After you finish, you can move around. You can draw another rectangle, and you can continue to, just like on Google Earth, you can visualize the dynamics of the changes. So it depends on the internet speed, but hopefully it will come up in just a few seconds. So what this one is doing is basically use Google Earth Engine to retrieve all the landscape imagery and then combine them together to generate annual landscape imagery, and then to create an animation. After that, it's going to use some packages to add the text, a label, and animation into the GIF. So hopefully it will work. If not, this is the kind of something like this. So I'm hoping the internet might be a little bit slow. We can come back after that. So first, before I introduce the package, I would like to briefly introduce, because there might be some new Earth Engine users. So I would like to briefly talk about the Google Earth Engine and Google Earth. So I'm sure 99% of you have used Google Earth before, and Google Earth basically is just a virtual globe. You can navigate, you can see the imagery and the buildings and terrains or something like that. But you probably noticed that you cannot do any analysis. So, and the Earth Engine is the engine behind the Google Earth. So if I use the analogy here, Google Earth is just like image viewer on, for example, Windows computer. And Google Earth Engine is just like Photoshop. So you can do all kind of advanced geospatial analysis, imagery processing. And it's very, very powerful. all you need is just a browser, and you don't need anything else. You just need to learn some coding skills, and then you can use this to produce a lot of applications. And one of the very powerful thing about Google is data catalog. So in the past, if you're doing remote sensing research, probably you need to go online, you need to Google and to find different agency, for example, NASA, USGS, or European Space Agency to download their satellite data. And so probably 70% or 80% of the time that for your research, you are basically dealing with the data. So Google Earth Engine is very nice because now you no longer need to download the data. You don't need to store the data. Everything is in the cloud. So in that way, you can focus more on your algorithm and your research rather than managing the data. And you can pretty much have all the data to almost all the common Landsat, not the Landsat Sentinel and MODIS and climate weather data, everything that you think of. If you the data that you want are not available in the data catalog, you can upload data to your account, so you can still have access to the computational power of Earth Engine. And right now it has 30 petabytes, so it's still growing. And I highly encourage you to try this one out. And this is the traditional, not traditional, the JavaScript code editor. So if you first get started with Earth Engine, most likely you're going to start with this one. And so if you see from here, this is the code editor in the center here, upper center, and you have the map there. You can display the data, you can show the results. On the left side is where you store your scripts, and you can also check the API documentation, also your data. On the right is where, when you query the data, it's going to return the outcomes. You can do the plotting, that kind of stuff on the right-hand side here. And lower right corner here, I provide a kind of simple JavaScript that you can, if you want to try it out, you're welcome to. By the way, so Earth Engine is free for research, education, and non-profit use. Everyone is welcome to sign up for research purpose. And so today my talk is focused on the Python API. So first, I would like to bring to your attention that the differences between these two API. So the JavaScript API, if you see from the list, the bullet points in here, is pretty much all the Earth Engine documentation and tutorials are written using the JavaScript API, and it's easy. And also the built-in authentication, and also you can have access to the Earth Engine app. But the limitation is that you cannot install any additional packages, so you rely on just the code editor. Python API is more flexible because most of the users, I think, if you're starting doing programming, most likely you probably pick up Python pretty easily. But the downside of the Earth Engine API, Python API, is that the limited documentation is very limited. There are not many tutorials on this one, but the advantage is that you have a lot more choices. For example, in terms of IDE, you can use Google Colab, you can use Jupyter Notebook. You can also utilize the Python ecosystem. There are so many packages that you can utilize. And one thing I also like is you can access the local data. For example, if you have vector data, you have raster data, you can access directly, and you can integrate those data with Earth Engine data. And lastly, deep learning. Okay, so this is a very hot topic right now, and it's nicely integrated into the Earth Engine API. It's not very easy to do with the JavaScript API. So the motivation here behind the geemap package is that, for example, I'm trying to here compare these two APIs. If you're using JavaScript API, you have everything. So for me, I think the Earth Engine, the functionality can be grouped into two categories. The first category is basically computation, and the second category is visualization. So in terms of the similarity between these two API, the computational functionality, I think, is pretty much the same. You have all the same functions, although there are some syntax differences, but the computation power is the same. The differences is the visualization. So JavaScript, if you see from this checkbox, red checkbox in here, these are all available in the JavaScript API, but it's not available in the Python API. So the motivation is that I want to implement this kind of interactive components so that you can basically have the same thing, this interactive GUI. You can also do that in Python API. And that's kind of the motivation. But this is the package that I developed actually originally was because I was teaching my undergraduate students how to use the Earth Engine. So I taught Python. And at that time, it was not very intuitive because students feel a little confused because there are lots of source code you need to write in order to load the data into the Jupyter notebook. It's not interactive. And so that's why I developed the package for my students, and then I released to GitHub, and it kind of the community like it, and I continue to work on the package. Okay, so that's the motivation. Now let's dive into the package. So it's basically a package for interactive mapping with Google's engine and IPyLeaflet and IPyWidgets. So I try to later I'm going to show you some of these packages. These are very important. Otherwise, the package, the geemap will not be possible. You can go to the GitHub link. There are lots of resources that I put on the GitHub webpage. So here I would like to mention some of the key dependencies. Okay, so the first one, Earth Engine API. So this is the key for the computational power of the package. And the IPyLeaflet and the Folium, these two packages are the plotting. So if you need to visualize the data, you need one of these. And the IPyWidgets basically is similar to the JavaScript that you can have all kind of buttons. You can have a drop-down list. You can have a input box. So this is where you can interact with the user. And the BQ plot is for the one for doing plotting. If you need to plot something using Earth Engine data, for example, matplotlib or something like that, this is the package that integrated with the with the Jupyter notebook. And Voila is the package that at the end you can turn your Jupyter notebook into web application. Basically, you can publish your notebook to the web so that people without any coding background, they can still use your application. And so the package is designed to run on either Jupyter notebook and Colab. So first you need to install, you can install using pip, or you use Conda, or you can install from GitHub. I highly recommend you use Conda because if you use pip, if you have some existing Python environment, sometimes the IPyLeaflet package have some dependency conflict, and some users reported that they were not able to display the map. But if you use Conda, most likely everything will be resolved automatically. So you can check my tutorial. And lastly, because the package is being actively developed, so sometimes I don't push the update to Conda or to PyPy every day. So if you want the latest one, you can use the geemap.update package, and to install that one from basically is similar to the same as this one, GitHub, but you don't need Git. Okay, so not every user on their computer has the Git installed, but if you can use this one, run this one on your Jupyter notebook, you should be able to update to the latest version. You can also use a Docker. So right now I'm working with Tyler Erickson from the Earth Engine team to hopefully integrate the geemap package into the Docker image. It's still a work in progress. So hopefully we have some update in the future. And like I mentioned, there are two environments you can run. You can either in the Google Colab and Jupyter Notebook. And I would like to point out the differences between these two. Most of the time, I would highly recommend that you use Jupyter Notebook, but I also understand that some people don't have the skills to set up Jupyter Notebook on your computer. You can use Colab. But the differences between these two is that the Colab currently does not support IPyLeaflet. So there are two plotting backends. Basically, when you're trying to display the data, you can either use Folium or you can use IPyLeaflet. And Colab support Folium, but does not support IPyLeaflet. So Folium package is more like a static map. Once you display the map, you cannot, basically there's no communication between the front end and the back end. Once the map is displayed, it's there. You can only zoom in, zoom out, and that's it. If you, for example, you want to use click the mouse, you want to get the coordinates, and then you want to use the coordinate to extract the Earth Engine data, you cannot. So this is not possible with the Folium package. I was want you to know that. And it's very limited. You can add data, that's it. Also make sure that you use the import geemap.ee Folium as geemap. So if you see the two scripts in here, there are some slightly differences. So if you use Colab, you need to install the package every time when you run a Colab section. So you need to put this line at the beginning. And then the import, it's not import geemap, it's import geemap.ee Folium as geemap. And then everything else are very similar. So using this package, you can use access to the function map.addLayer or set center or set center object. So those functions are the same as the JavaScript API. So if you're coming from the JavaScript API, I'm sure you'll be very familiar with these functions. The syntax are pretty much the same. And the other thing I want to point out is that if you're using the Google Colab, make sure that at the end, if you see the second last line here, map.addLayer control, okay? By default, it's not adding the layer control. So if you add multiple Earth Engine data layers, make sure you use this one. Otherwise, you cannot turn layer on and off. So this is kind of main differences between the two. I also put out a notebook example here. If you click the link on the left side, it will take you to a kind of a Jupyter notebook. So on my GitHub webpage. And from there, you are welcome to just click the icon run in Google Colab. And you should be able to just execute the code. And but
Qiusheng, you're muted.
okay, can you hear me?
Yes.
Okay, so this is about the environment, like how you can run the package. And I also published a short article about the introducing the package. So if you're interested, you can click the link to read the application, the paper. And if you find the geemap useful, I would appreciate if you cite the paper to support my work. So next, I'm going to show you some documentation how you can utilize the geemap. So I just recently redesigned the documentation, so you can click the link, and on the left side you can go through to find some of the tutorials and common functions. And one thing I want to point out is that this one is nice because for each function right now, I think I have hundreds of functions in here. You can click the link. You can see the source code behind each function. So if you're interested in learning like more about the source code behind the package, you're welcome to go to the webpage to explore details about each function. Okay, next I'm going to show you some tutorials. And in the past, I think I started the package started in I think late March after we moved to online teaching because of the COVID-19. And then I was actually teaching the course, so I was developing the tutorial for my students. And so eventually I thought, okay, maybe I'll just develop some general tutorials and put online. Maybe other people might find it useful. So this is what it's ended up with. Right now I have 34 tutorials, and the total length is 8 hours, 30 minutes. And each tutorial is only 15, 20 minutes like that. And you're welcome to go through because today I don't have time to go into detail of each one, but you're welcome if you have time to watch the tutorial. And although it's only 10, 15 minutes, but keep that in mind, the most time consuming part is to develop those functions being used in the tutorial. So recording a tutorial actually is pretty easy, but actually it takes sometimes 10 times kind of an hour more than the length of the video actually to develop the package and also to come up with the Jupyter notebook and to demonstrate all the functionality about the package. So I hope you find it useful. And this is the list of the tutorial. You're welcome to click the link above here to go to the GitHub webpage. So for all the tutorial, I have a video, YouTube video. I also have a short GIF animation. So if you don't have time, you can watch the animation to get the highlights. And you can also get access to the notebooks. Because to me, I like everything to be reproducible. So everything that I implemented in the notebook, you should be able to implement it as well. So if you click the link, you should be able to navigate to the web page. And from here, I have all the tutorial. You see here all the animation. And I stopped updating this web page because these animation are kind of the file size is big, so it takes a while to load, and I no longer add the animation to here, but it's overall on the web page. And so 34 tutorials. I'm still working on some other tutorials, so watch out for my YouTube channel for updates. So lastly, I want to demonstrate some of the features of this package so that you might have some idea. I don't have time to go into each individual one, but I want to give you an overview what's available in this package. So in the future, if you, I need something, and I saw that one somewhere in the past, then I can use this package. So first of all, if you're coming from JavaScript, one of the things about geemap is that you can automatically convert your JavaScript to Python. So and you can do it directly within the Jupyter notebook, or if you already have some JavaScript on your computer, you can do batch conversion to just a few lines of code. You can convert all your Python script, JavaScript to Python script. But I want to let you know that this is only good for the computational script. If your JavaScript has a lot of interactive component, for example, Earth Engine app is not going to work. Okay, so but you can watch the video to see how this can reduce the time if you want to convert from JavaScript to Jupyter notebook. And also you can source data, you can source all the Earth Engine data catalog, and just one click to import the data, and then one click to execute the code. So basically you have the same functionality like in the JavaScript code editor. You can source the data and you can easily access the data. You can also search the API documentation. So most of the time you might be searching the API all the time. So if you're working in the Jupyter notebook, I also would like to let you know that you can also search the API and also your personal like data from your account. Just one click and you can get that one into the Jupyter notebook to see. You can also add legends. So for example, lane use, lane cover, or you can customize. So it's very flexible. You can also copy the color table from the Earth Engine JavaScript, and you automatically convert the legend to HTML. So also you can have a lot of base map to choose from. If you use JavaScript API, you only have the base map from the Google, so it's very limited. But here you have a lot more options. You can have any XYZ or WMS. Okay, there are a lot of things available on the internet, so you can easily add those into the map. You can create a split panel map. Okay, just like this. If you want to visualize the changes, this is just a demo. So only one line of code, you can create a map like this. If you're trying to do this one in JavaScript, it might take you lots of lines of code actually to develop. So try to simplify the process. You can do it very easily. You can also use the inspector. So in here, inspector, you can just like in code editor, you can click and you can show all the values for each data layer. Okay, so it's very nice if you want to visualize quickly, want to extract the pixel values. You can also do interactive plotting. So like I mentioned earlier, the Java Python API, because you can utilize a lot of map plotting packages, for example, matplotlib or bqplot. So this one is developed using bqplot. You can display the spectral signature for landscape for hyperspectral data. You just need one click, so no coding required. You just add the data and then you can do the plotting. You can also extract the pixel value as a CSV or as a shape file. You can click, and then all you need to do is just to write 1 or 2 lines of code. You can export the data directly as a CSV to your local computer or as a shape file. Okay, you don't need to export to your Google account, and then you can open your CSV file on your computer to visualize the data. You can also create a landscape time lapse. So for example, like the one I showed you at the beginning, you can draw a rectangle and then you can do animation create lane set time lapse for any location on Earth. You can also use the so-called time series inspector. For example, net image 1 meter resolution, any location on the US, or you can use the lane set data, annual data anywhere. So you just draw a rectangle and then you can have the data, no coding. You just load the Jupyter notebook. You can also access the local swap file. So if you use JavaScript API, you need to upload data to your account, and sometimes it's very annoying because if you only have a very small area, you want to test your data, you can quickly use this one to load data. And but it's not going to work for large data set. If your swap file is very complicated, you have a lot of vertices, it's going to exceed the uploading limit. So this is good for testing for small data sets. And you can also load your local raster data set. So this one utilize the Xarray and LeafLab package, and you can load your data set. So in this way, you can interact the data with Earth Engine data. So sometimes you have data on your local computer, but you don't want to upload the data to the Earth Engine account. You can use this way. But I want to point out that right now you cannot do analysis between these two. It's good for visualization and comparison, but it's local data. If you really want to utilize the computational power, you still need to upload to the Earth Engine account. And next one, so this is like you can publish interactive Earth Engine maps to be embedded into social media. So for example, if you are on Twitter or Instagram or Facebook, you want to develop some maps using Earth Engine, you want to other people to access, but not everyone has the Earth Engine account. So you can actually use this one to just one line of code. You can publish the interactive map, and then you can put that one to social media, and people will be able to interact with your map data layers, zoom in and zoom out. Okay, and this might be the second last one. So this is the one actually the demo I showed you at the very beginning, right? You can turn your Jupyter notebook into an Earth Engine app using Voila. So Voila is the open source package to turn your Jupyter notebook onto web application or website. You can also host your app on Heroku or Android. These are kind of a commercial, but it has free version. So if you want to try it out, you are welcome to do that. So it's very nice. So this is the one that you can use to publish your data. So it's similar to the JavaScript version of the Earth Engine app. So you can also do that using Jupyter notebook. So like we see in here, you can have this interactive component using IPy widgets, and then you can change the opacity. Way more than that, it's very powerful. Okay, so that's kind of the brief introduction about those key features, and you're welcome to explore the more tutorials on my GitHub account or the YouTube channel that I have more detail about each functions. Because of the time, I don't have the time to get into every features about the package. But if you want more tutorials, okay, you can use the other GitHub repo, 360 Jupyter Notebook examples. So this is the one actually I converted the Earth Engine, the documentation. It has a lot of like examples. So I convert all the examples from JavaScript to Jupyter Notebook. So you can see the general like structure here is the same as the Earth Engine JavaScript documentation. So if you're reading the JavaScript documentation, you want to find something, the counterpart of the Python, you can come to my notebook, and all you need to do is just to click the link, and it will take you to the notebook. From the notebook, I have the run in Colab. So all you need to do is just to click the link, and then you should be able to run the source code within Colab. So everything is set up nicely so that you don't have to spend time to do the conversion between JavaScript and Python. And lastly, if you want more tutorial, or you have something that you want me to implement, you're welcome to submit a feature request on my GitHub repository. You can also follow my blog or my YouTube or Twitter. But I highly recommend that you submit a request on the GitHub repo. In that case, everything is recorded, so I can come back to fix those issues or implement those new features. And if you send me email, now I receive a lot of email every day, so sometimes it might be inundated, so unable to really get back to the email. So for example, if you see from here right now, I have already solved almost more than 100 issues from all the users. So this is the community. So if you report an issue, it makes the package better. So I really appreciate if you reported one on the GitHub repo. And I think that's all for the my presentation. And if you have any question, you can email me or you can ask me on Twitter. Thank you very much.